Okay, we can now determine the concentration of our unknown samples using our absorption measurements. So what we're going to do is we're going to do this longhand for one sample, but then we're going to do it all in Excel. And the task is really simple. We enter the data into Excel, and then we calculate the concentrations using the equation from the standard curve. And so what's going to happen is we're going to know the absorbance that we measured for each sample. We'll know the slope and intercept from the standard curve. And from that, we will calculate the concentration of nickel. So effectively what we're doing, if we look at it graphically, this is the standard curve we got. If we look at sample one had an absorbance of 0.359. So that's right about like around here. If you take that, you go across here until you hit the line and then drop down and read the X value, that X value is the nickel concentration. So it's around 0.7, 0.8, something along those lines. And so we're not going to do it graphically, of course. We're going to use mathematics, and we're going to use the equation for the standard curve to do so. And so let's do sample one mathematically. So the equation we had is absorbance equals 5.0517 times the nickel concentration minus 0.0076. That can be rearranged to solve for the nickel concentration to give absorbance plus 0.0076 divided by the slope. So let's go ahead and do this for sample one. Our nickel concentration will be equal to 0.359, that's our absorbance, plus 0.0076 divided by 5.0517. And doing that out on the calculator gives 0.0726 molar, or moles per liter. So that's the value we got. If we look back at our plot here, that's pretty reasonable for what we had there. So what we're going to do is we're going to do the same math for all of the samples using Excel. So this is the Excel file that has, we've reminded ourselves what the concentrations are, we've reminded ourselves what the mathematical equation is between nickel concentration and absorbance, and we have our list of all of our absorbance values. So let's go ahead and redo sample one here. So that's going to equal, we want to have the absorbance, which is cell number B3, plus 0.0076, I'll put parentheses around that, and then we'll divide by 5.0517. And we get a number that's the same as what we had earlier. And now to do all the rest of these, instead of doing that equation over again, we can just use the little box right there on the bottom right, drag that down, and do it. So for the first 21 samples, there are our absorbance values. One needs to be careful that because of our absorbance measurements of only 3 significant figures, these concentrations should be reading in 3 significant figures. So just take that into account. So that's how you determine all the concentrations. So we now know the concentrations for all of those samples.